Well, thank you so much for these very kind words of introduction. It's a real pleasure to be here, an honor, and I have to say quite a privilege to be the first one to give a lecture, not only to all of you, but also the first one in this room to give this lecture. So thank you, Andreas, for thinking about me and inviting me. Well, I thought I would give you a lecture on climate change, which is, I would say, perhaps the biggest global public policy problem that the world is facing and that we are facing. And I will talk about why it is at the moment unresolved and walk you through some ideas of how we can address it. The plan of the lecture today is really to first give you a little bit of the science of climate change, which I think most of you know, but I just want to sort of put us all in the same spot. Then I want to actually do a very short game with you and sort of engage you, and then walk you through 3 different public policy solutions that are sort of being discussed and being applied also to address this climate change problem. Okay. So the basic science of climate change, I think, is rather well known. We know that the sun adds energy to the earth, but of course the earth also loses energy, heat energy. And when emissions are too high, meaning higher than what the earth naturally absorbs, for example, trees and soil and oceans, then the concentration of greenhouse gases in the atmosphere will increase. And as the concentration increases, it traps the heat in the atmosphere and basically global temperature rises. And that has multiple effects on ecosystems, on societies, on many aspects of our lives, which you will see a few examples in a minute, but basically it's this rise in the concentration of greenhouse gases that contributes and drives climate change. And the greenhouse gases, I mean, most of you have probably heard of carbon dioxide, but there are many others, but we'll focus mostly on carbon dioxide. Now, here, this is the problem, right? I mean, this is the global problem. These are global annual CO2 emissions divided up by world regions. And I think the first thing to really note when you look at this graph is that emissions continue to grow. They have not yet peaked. If you, and I don't think I have a pointer, but if you look here, you see a little dip here, right? And then it goes back again. And that little dip was, of course, the global recession around COVID, the COVID pandemic that we experienced 2 years ago. So global emissions have not peaked. The second thing to notice, and I'll show you a little bit more detailed graph on this afterwards, is that actually in the European Union, in the United States, the emissions have peaked, but they continue to rise in China and now increasingly in Asia. Yeah? So this is the emissions. And of course, if you continue to do lots of emissions, this accumulates in the atmosphere, and basically the concentration of carbon dioxide has been increasing quite significantly. There's scientific evidence on that, how much it has increased. And the primary driver of that increase in emissions is, in fact, by now industrial activity. So basically fossil fuel industrial activity. Consequence, global temperatures increase, and this is the anomaly in global temperatures as measured by scientists. Now, the consequences, I think many of you have seen this. So let me just give you, since we are now in Germany, and you're now in Germany, I mean, this is a picture here from the Ahr Valley, which is a valley in the west of Germany, where there was a sudden flood. And here this article in Nature actually states that climate change was implicated in that increase, in that flood, which was quite deadly. I mean, there were many people dying, But of course, fires are a big problem. Droughts are a big problem. So this is a big issue. Okay, so let's play this. Let's first ask, do a little survey, and then play a little game. And so the survey. I mean, I just want to hear from you, who actually in this room believes that climate change is happening? Hands up. Okay, that's already great. You all believe in science, and I think that's great, since you are here at a university after all. So, who believes that climate change is actually man-made? All right, I think it's also everybody, I hope, at least. But well, I could ask the counter question, but that's perhaps too complicated. And who agrees that we all should actually do something about climate change? Okay, so we all agree, but why do emissions continue to grow, right? I mean, everybody in the world knows this problem, right? Not everybody, but many, many people know this problem, and still emissions continue to grow. Okay, I think one reason, and that's the little game I want to play with you, has to do with collective action. And so let me try to explain this or play the game with you. Imagine you have 10 euros or dollars. Yeah, each of you has 10 euros, and I'm Mother Earth. I'm giving you a pledge, a promise. If you invest €1 into climate mitigation measures, so you invest into protecting the climate, I'll give you back €2 to all of you, right? So one of you gives €1, I give €2 to the common pot that you all get back. Okay, so who would be ready to put in €1 into the pot? Okay, there's many of you, but how much do you get back if you put €1 in? So we are 50 in the room, right? So you put €1 in, Mother Earth gives back €2. €2 divided by 50 gives you what? 4 cents, right? So the return on your €1 investment is actually 4 cents. Think twice whether you really want to invest €1, right? And I think that's the core of the collective action problem. And so the way to solve this is basically that, I don't know if you've understood this, but you seem to be nodding. So look, the return for an individual that puts in €1 is actually quite small, right? I mean, who of us is ready to not take a plane somewhere, or not consume red meat, or not drive your car, etc., etc. I mean, we all do this because we know that our marginal impact is actually quite small compared to the return that will be given to the rest of the world if we don't engage in this. So that's the core of the collective action problem. And the way to solve this is basically, if I was a sort of benevolent dictator, right, I would say, if you don't give the €1, right, you will be penalized, right? I mean, then I have a way of convincing you to actually pledge the €1, which is optimal. If each of you gives €1, we all would benefit tremendously, but we need to be sure that each of you actually gives that €1. So that's a little game, and that little game actually is called, I mean, sort of the basics of this is the tragedy of the commons problem. This was developed by Garrett Hardin in a famous article in Science in 1968. And the basic idea is, if there is no ownership of a good, and people can just use that good, they tend to overuse the limited resource, and because the private calculation is different from the optimal calculation of the world as a whole, and so you can do this with basically a lawn where sheep can graze, right? So if the lawn doesn't belong to anybody, every individual farmer wants to send as many sheep as possible on the lawn to have the sheep graze, right? You want to send these sheep on the for grazing and maximize your profits. But if too many farmers are there and too many sheep are on this lawn, then actually it will be overused, and after a while there will be no lawn left. So you have to limit the use of the lawn by finding ways of basically coordinating actions across all the farmers that want to use this lawn. This was the Harding article in Science, the analogy is basically, instead of the lawn, you have a limited carbon budget, right? I mean, which I showed to you, the limited carbon budget, if it continues to increase the concentration of CO2, then at some stage it's exhausted, and basically climate change will become worse and worse and uncontrollable. Yeah. So this is, I would say, the basic problem, and I'll talk about some criticisms of this problem and the way I characterize the problem also in a minute. But let's just sort of briefly go through the three big public policy solutions that I think are currently on the table. The first one is basically sit around the table, have an international climate negotiation, the so-called COP process, Conference of the Parties. So COP stands for Conference of the Parties. What is that? I mean, that's basically signatories to the United Nations Framework Convention on Climate Change, UNFCCC. Many of you might have heard of this, but that's sort of the core of the global climate negotiation architecture. And the basic aim is to really sit around the table and agree jointly on emission reductions. And I'll talk a bit about why that is only half working. Then the second solution that's being discussed quite a bit is so-called climate clubs, and I'll discuss those. And lastly, there is, of course, the hope in technology and the economics of decarbonization. So very quickly, I mean, yeah, I'm doing okay on time, actually. So the COP process, yeah. So in 1992, countries joined an international treaty, the United Nations Framework Convention on Climate Change. Basically by 95, countries launched negotiations to strengthen the global response to climate change. And then there was the Kyoto Protocol, which was quite an important international agreement, which led to a commitment to a legally binding commitment to reduce emissions for some countries. 36 countries actually signed the binding targets. The US did not ratify it, and Canada actually withdrew. And while the countries with binding targets actually surpassed their reduction targets globally, as we saw, emissions continued to grow, right? I mean, they didn't go down, they continued to grow, and they continued to grow actually faster than before. And then, you know, there were a few further summits, COP summits, and in 2015, the Paris Agreement was adopted in Paris, obviously, and it marks the next step in the UN climate change regime. And the limits of the Paris Agreement really come from the fact that there is, I mean, the core is a pledge and review approach. So let's just explain 1 second what the pledge and review approach is. The idea is basically to pledge emission reductions, yeah? And if you pledge these emission reductions, after a year or two, you're being reviewed by your peers and supposedly show that you have done your job, and you pledge further, more ambitious emission reduction targets. So the hope was that this would enable an upward spiral of ambition over time across countries. But there is this substantial free riding problem, and which we explained in the game. We played the game for it, and the core issue of the Paris Agreement, arguably, is that the pledge and review approach does not involve binding or mutually committing enforcement mechanisms, which therefore means that countries, individuals tend to free ride. And there's a nice paper by McKay, Crampton Ockenfels, Axel Ockenfels in 2015, which sort of, I mean, the title I think is illustrative, price carbon. I will do it if you will, right? So it's about how do we get the commitment, the mutual commitment across countries, that countries commit to binding reduction targets and are ready to accept enforcement in case they are not doing what they promised to do. And the game I played is actually from that paper. It's a bit more complicated in this paper, but that's the idea basically. Okay, so I mentioned I do want to mention in all fairness that there is some literature out there that argues it's basically not a collective action problem, global collective action problem, or at least that it's observationally equivalent. So there's this paper here by Acklin and Mildenberger, and they emphasize very much that climate policies generate winners and losers, and so it's less the fact that countries sort of are engaged in a sort of free-riding perspective or free-riding conflict. It's much more the fact that within countries there are distributional implications of climate policies, and those that are powerful tend to be those that actually benefit from carbon oil revenues and from the oil industry and from using, of course, oil and gas and coal as means of generating energy. So this is an alternative interpretation, and I guess it would go too far. I mean, I still think the collective action problem is sort of central, and this can be also subsumed under the collective action problem. But okay, I think this is a debate that is interesting to pursue a bit further in a different setting. Okay, very quickly, climate clubs. What's the idea of climate clubs? Well, the idea is that instead of having voluntary commitments, you aim to overcome the free riding problem by forming a club of countries that commit in a binding way to tougher climate action and penalize countries outside of the club that do not engage in a similar level of ambition. This idea was initially put forward by Bill Nordhaus, Nobel laureate in economics. So basically what he says is, okay, we have to form a club, right? And the club needs to have a high price, for example, a tax on carbon emissions, on greenhouse gas emissions. And it would ideally be the same carbon tax in the entire club. And countries outside of the club that do not want to commit to similarly high levels of pricing of CO2, those countries face a penalty. And the penalty that Nordhaus proposes is to have tariffs on all trade with countries outside of the club. Yeah? So if a country outside of the club wants to export something into the club, it will be penalized with a heavy trade penalty, a tariff. In this paper, he also acknowledges actually that if you want to do this, you have to significantly reform the rules of the World Trade Organization, WTO, and that's an issue. So that's an issue where we started with a colleague from Brussels, Simone Tagliapietra, where we basically said, look, I mean, yes, we can reform the WTO rules, but if you agree on a reform of the WTO rules to achieve your climate club, basically it's quite close to actually agreeing on a new global climate deal that is quite binding, right? So it's actually very difficult to change WTO rules in favor of a climate club idea. And therefore, it's not a very realistic option to pursue. So what we proposed instead is to use the so-called carbon border adjustment mechanism as a way to incentivize club membership and accelerate decarbonization. So what is a carbon border adjustment? Well, the basic idea is very simple. It's when you export a good to a country, that good contains, of course, CO2, right? I mean, so if I export this computer from China to Europe, well, the computer was produced probably with lots of oil and lots of coal electricity, etc., coal-generated electricity. So basically, you export CO2, right? You export CO2 contained in the production of that good. So as the computer comes in, I basically price tax the computer as I would tax the computer that was produced domestically. If it had been produced domestically under tougher rules. So for a country outside of the club, it would face the same kind of carbon taxation than a country inside the club. And you can show that under certain conditions, this can actually be done in a WTO compatible way. I mean, this is quite controversial, but if you, under certain design assumptions, I think you can do it. And you could, in that way, generate some sort of a club that incentivizes countries to gradually accelerate their decarbonization efforts and price CO2 emissions accordingly. So the EU, the European Union, has actually in place a carbon border adjustment mechanism. It was just decided. The problem is that this is probably not big enough to sufficiently incentivize other countries to accelerate their decarbonization efforts. Okay, so just to, and now I need to speed up actually. So just to say the idea was to start a club with the United States and the EU and bring in China as soon as possible. And so here's the problem. I mean. These are the same chart as the first one that I showed you. I mean, these are greenhouse gas emissions, and what you see is that the EU and the US have peaked. China's emission continue to actually grow quite rapidly, and that's related to coal power in China. And I'll not talk about historical emissions, but because I need to accelerate. But basically. The problem of the climate club idea is still that the world is quite far away from having sufficient number of countries actually doing significant carbon pricing and being ready to penalize countries outside. And China might see emission peaks, but elsewhere, actually, emissions continue to grow even more rapidly, and that's, I think, also useful to see. I mean, that's Asia. You see that Asian emissions outside China continue to grow quite rapidly and are forecasted by the International Energy Agency to actually go up quite a lot. Now, last point is and I think I have 5 more minutes if I'm not mistaken. Okay. Because I looked at my watch, we started 20 past. I started 20 past, so I have 25 minutes. I have 5 more minutes. So the economics of decarbonization. I mean, what's the idea here? I mean, the idea is basically that the decarbonization of economic activity is actually happening, yeah, but it's happening too slowly. And I want to illustrate this with this chart. So the orange one gives you annual CO2 emissions. That's the chart we saw all the way at the beginning, right? I mean, it continues to go up, actually. Emissions continue to go up. But, and this is the interesting thing, emissions per unit of GDP, yeah, so per unit of income generated, actually go down, right? And if we only could sort of bring this curve steeper down, right? If only we were able to do that, then of course at some stage emissions would fall, because the emissions are related to the economic activities. As I accelerate my decarbonization, I will be able to actually reduce total emissions as a whole. So the question is it going to be possible to basically bend this curve more quickly downward? Yeah, and so problem is so far it's not there. What would have to happen is that basically this has to increase by a factor of 6. We are now at minus 1.6% per year. So every year per unit of global GDP, we are emitting 1.6% less CO2, right? I mean, this is the historical average from 95 to 2018. So we are actually decarbonizing at a speed of 1.6% each unit of activity. If we wanted to reach zero emissions, I mean net zero emissions by 2050, you can put in various assumptions, which we did in a paper here. You actually have to accelerate that speed, bend that curve by a factor of 6. Yeah, so it decrease your emissions per unit of GDP per year by actually almost 10%, right? So it's a massive acceleration of decarbonization. Now, is it actually possible, right? Is this possible? And I think this is probably one of the most interesting and important questions. How quickly will technology allow us to bring down the price of alternative ways of generating and green ways of generating energy, right? And so one statistic here, and I have a whole bunch of charts. I mean, I just want to show you this one chart here. Is the so-called levelized cost of electricity, which is basically trying to capture how much does it cost to produce a megawatt hour of electricity. I mean, how much does it cost depending on the way you do it? Solar, photovoltaic, wind, coal, geothermal, nuclear, and gas combined cycle. And if you look at the numbers in 2010, solar and wind were the two most expensive ways of generating electricity in 2010. That's only 13 years ago, right? I mean, so many of you were perhaps still kids, but it's not so long ago, right? So 13 years ago. In 2020, solar and wind actually was cheaper than all the other alternatives. It's become a little bit more expensive in 23 again because cost of capital has increased, but it still seems to be cheaper. So the simple generation of electricity by now, even in the Gulf states where you get very cheap oil, is actually cheaper to do it with photovoltaic than with basically oil or gas, right? So I think there's some hope here, right? I mean, the electricity system can already be turned green at relatively reasonable prices, but it's not as trivial as that because there's storage. I mean, there's all kinds of additional problems that we have to discuss, and we don't have time for that now. But basically, there's also differences across jurisdictions. I mean, this chart shows that in the Asia Pacific, it's not yet the case. But I think I need to conclude here by essentially with three very quick last slides. So the first is really climate change is real and it will be increasingly felt. I think we have all agreed on that, right? Global cooperation on carbon pricing or binding emission reductions remains, I think, still quite unlikely. The climate club solution that we've advanced can contribute to solving collective action problems, but incentives are currently way too weak to really bring on board countries in Asia, in China, of course also in Latin America that want to develop, right, and want to use the cheapest way of getting energy to develop. As long as they think, or as long as many applications are cheaper with fossil fuels, they will use it because it cannot be a trade-off between development and using climate action. Especially emerging economies see rapid increases in emissions, while advanced economies have had a lot of historical emissions. But they decarbonize now, but also too slowly, right? So what's the hope? I mean, the hope is that basically the trade-off between growth and decarbonization becomes less strong, thanks to falling prices of renewables. I think that's one really big hope. The other hope is, of course, that there's an increasing recognition in populations among all of us that climate change needs to be addressed and that people are actually ready to take action. And so just to give you a bit, since we are policy school, so what do I think we need to focus on, policymakers need to focus on accelerating green innovation, supporting the rollout of green technology, in particular in emerging economies. Think about regional, local regulation and public sector action that influences the cost of the rollout of green technologies. And all of this is also actually quite a big macroeconomic task. It has business cycle implications, growth implications, fiscal policy implications, monetary, financial, labor, and distributional implications, all of which will be part of the seminar I will give this year, and which I want to advertise here, a forthcoming book with a few colleagues at Cambridge University Press. It will only appear in February, unfortunately, but a lot of what I discussed is in this book, and will be also in the lecture and in the seminar that we will do this winter. Thank you so much for inviting me.